Question 1. So we're told that the plane is 73 metres long. So given we've got to give our answer in centimetres, why don't we turn this into centimetres now? There are 100 centimetres in a metre, so we've got to do 73 times 100, telling us that the plane is 7,300 centimetres long in real life. Now the scale of the model is 1 to 200, so in real life is 200 times bigger. So to get to the size of the scale model, we have to divide by 200. So 7,300 divided by 200 means that the length of the scale model is 36.5 centimetres. Question 2, so we've got to write down the nth term expression. So the first part of the expression is just how much we're going up by each time in this arithmetic sequence. So you can see we're going up in 4s, so our first part of our expression is 4n. We then have to do the adjustment. So the second part of the expression is the adjustment we need to do, and this is what we call the 0th term. So imagine a number pushing to the front of the queue. What would go in front of the 7? Well, you can see as we read right to left, we're going down in 4s. So we'd have to take 4 away from 7. 7 take away 4 is plus 3. So the adjustment would be plus 3. So our nth term expression is 4n plus 3. Question 3. Now I thought this was very difficult so early in the paper. So what do we know? The ratio of red counters to blue counters is 2 to 13. So the ratio has a total of 15 shares. Now we're starting off with 90 counters in the bag, so it's easy enough to see what our starting position is. So 90 counters. So how do we get from our total ratio of 15 to 90? Well, we multiply by 6. So if we multiply the 2 and the 13 by 6 respectively, we can see we've got 12 red counters and 78 blue counters to start with the 12 plus 78 equaling 90. Now we're going to add some red counters, and once we've done so, then the ratio of the red to the total is going to be 1 to 3. So when we start adding some red counters, let's say we add x counters on, how many red counters are we going to have altogether? Well, we're going to have 12 plus x. And how many counters are we going to have in total once we've added on this x number of red counters? We're going to have 90 plus x. Now, once we've added these extra counters, the ratio of the red counters to the total counters is going to be 1 to 3, or a third. So we can say 12 plus x divided by 90 plus x gives us our probability of 1 to 3. So we've constructed an equation here which we can solve. So let's multiply both sides by the denominator by 90 plus x to give us this line. Now to get rid of this third, rather than multiply out, which of course we could do, I'm choosing to multiply both sides by 3 at this point to eliminate the third. So multiplying the left hand side by 3, we get 36 plus 3x equaling our 90 plus x. So if we then take away x from both sides and take away 36 from both sides, we get 2x equaling 54. Halve both sides, we get x equaling 27. So the number of red counters that Lee is going to put in the bag is an extra 27 counters. Question 4. So let's start off by popping 1 and 3 in the middle. A intersection B is 1 and 3. A intersection B means they're both in A and in B. Right, now let's then go and complete what is in A. Now we know that A comprises all the odd numbers in our universal set here, so we're just going to work through all these odd numbers, all these numbers here, and popping all the odd numbers into A. So we've already done the 1 and we've already done the 3. So the 5, the 7, the 9 and the 11 all go into this part of A. So the rugby ball A comprises all the odd numbers in the universal set. but with the 1 and the 3 being in the intersection. Now we can go and complete the rest of the B rugby ball by taking into account that A union B are these numbers here. Now A union B means it's either an A or B or both. So just working through all these numbers here, well, 1's already in the middle, so 2 we need to take account of, so there's the 2. 3's already in the middle, we need to add on the 4. We've already done the 5, but we haven't done the 6 yet, so we pop 6 into B. The 7's already accounted for, the 9's already accounted for, the 11's already accounted for, so it's just now 12 that we've got to go and pop into this part of B. So overall, the numbers A union B are all the ones inside the 2 rugby balls together. 1, 2, 3, 4, 5, 6, 7, 9, 11 and 12. So what numbers haven't we counted so far that are in our universal set? Well, we're just left with numbers 8 and 10. So they've got to be included somewhere inside the rectangle, but outside the 2 rugby balls. So question 5. Let's go and let the length of these little tiles be x, and let's let the width of the little tiles be y. So this length all the way along the top comprises an x plus an x plus an x plus an x plus a y. And what do I know that equals to? Well, that equals 123. So I've formed my first equation. 4x plus y equals 123. Now looking at the height of the overall height, we've got x plus y equaling 67. So there's my second equation, 2x plus y equals 67. Now I can immediately eliminate y by subtracting the second equation from the first. So 4x take away 2x is 2x, y take away y is nothing, 123 take away 67 is 56. So 2x equals 56, so x equals 28. So I can, so my x equals 28. Now what about working out my length y? Well, I can take either of these equations. I've taken the second one, my 2x plus y equaling 67, and I've substituted in my x value of 28. So 2 lots of x, 2 lots of 28, plus y is 67. 2 lots of 28 is 56, so 56 plus y is 67, so y equals 11. Now, a couple of ways, at least, that I could work out the area of the shaded rectangle. One way, the way I've done in red, is just to work out the 2 sides of the shaded rectangle. So the base of it, this length here, comprises 123, take away a couple of 11s, so that's 101, whereas the height of the shaded bit is 67, take away a couple of 11s, which is 45. So my shaded area, the shaded rectangle is 101 times 45, which is 4545. So that's one way of doing it. Alternatively, I could have said that my total area of the whole thing is 67 times 123, which is 8241. The area of each of the tiles is x times y, is 28 times an 11, and I've got 12 of these tiles, so the total area of the 12 tiles is 3696. So take away the 3696 from the total area. That's another way to get my 4545 final answer. Question 6, part A. So probably the easiest way to do this is just to do the 2 number trees. So I've broken the 96 down. 96 is 48 times 2, 2's prime, so pop a circle around it. 48 is 24 times 2, 2's prime. 24 is 12 times 2, 2's prime. 12 is 6 times 2, and 6 is 3 times 2. So basically my product of prime factors for the 96 is 2 to the power of 5 times 3. Doing a similar exercise on the 120, my product of prime factors there is 2 cubed times 3 times 5. Now the highest common factor is when I multiply together the numbers which are common to both lists. So I've got a 2 cubed, which is common to both lists, and a 3. So 2 cubed times 3, 8 times 3 is 24. Now for part B, you can do this by way of a Venn diagram, and that's what I've done in blue. So I've got the 3 letters overlapping, A, B and C, and I can see straight away that there's no overlap between B and C. There are no numbers common to B and C, so hence my 2 zeros here. What numbers are common between A and C? Well, I can see that I've just got a single 5 in common between A and C. What numbers are common between A and B? Where I've got a 2 cubed, a 7 and an 11. So that's how I've filled in these intersecting bits, the 2 cubed, the 7 and the 11, and the 5, the 0 and the 0. Just be careful, it's not that clear here. That's a 2 cubed and that's a 7. Alright, it's not a 2, 3 and a 7. That's a 2 cubed and a 7. So I can then fill in the remaining bits. So for A's got to comprise a 2 cubed, got it already, a 5, I've got a single 7 so far, so I need another 7, and there's my 11. So my A rugby ball's alright. Now with regard to B, I need to have in B overall a 2 to the power of 4. Well, I've got a 2 cubed already, so I need another 2. The 7 and the 11 already accounted for. And my C rugby ball's got to have a 3 and 2 5s. Well, I've got a 5 already, so there's my remaining 3 and 5. Now my lowest common multiple is when I multiply all of these numbers together. So that's a 7 times a 5 times a 2 cubed times a 7 times an 11 times a 2 times a 3 times a 5. So multiplying all those together, I get 646,800. Now probably a quicker way to do it is just to not bother with the Venn diagram and just work your way along from the 2 to the 3 to the 5 to the 7 and the 11, and just take whichever one is biggest wherever it may be. So at the 2, well, I've got a 2 to the power of 4 in B, so I take my 2 to the power of 4. What's the biggest number of 3s I've got anywhere? Well, it's just a single 3. Moving on to the 5s, the biggest one I've got is the 5 squared. Moving on to the 7s, the biggest one I've got is the 7 squared, and then my biggest number of 11s is just a single 11. So multiplying each of those together, I get the same answer. So I think probably that's the quicker method, but it is quite nice to see it in Venn diagram format for completeness. Question 7. So with these compound interest questions, it's really helpful if you can remember the quick way to do these. So you start off with the amount of money being invested, the 8,500. You then need to multiply this by the multiplier. Now with the 2.3% compound interest rate, our multiplier is 1.023. Had it been 4%, it would have been 1.04, 6%, 1.06, and so on. So that's where the multiplier comes from. And then the power that you apply to this multiplier is the number of years you're investing over. So 3 years, so to the power of 3. So just pop into your calculator 8,500 times 1.023 to the power of 3, and that gives us this number of dollars. So to the nearest dollar, that's 9,100. Now with part B, we were buying the house for a value of X back on the 1st of January 2015. Now over the first year it increases in value by 15%. So we take our X and we multiply this by 1.15. That builds in the 15% increase. So those two multiplied together would give us the value by the end of 2015. Now we take this value and then over 2016 it decreases by 8%. Now an 8% decrease is represented by a 0.92 multiplier. Okay, a 5% decrease would be 0.95. A 1% decrease would be 0.99. So we know that the original price we paid for it, if we multiply it by 1.15, and then multiply it by 0.92. That gives us our final value of 687,700. So I formed that equation. So if I choose to divide both sides by 1.15 times 0.92, I get x equaling $650,000. Question 8. I thought this part A was quite generous for 3 marks. So you've got to learn that density equals mass over volume. So we've got to work out the volume, so rearrange to make volume the subject. So multiply both sides by V, divide by D, and we get volume equaling mass divided by density. Our mass is 3.5, our density is 0.65, and popping that into a calculator, this is our answer. So to 3 significant figures, that's 5.38. Always just need to check there's no complication with the units. Well, there isn't here. Kilograms, kilograms, meters cubed, so we're fine. So no tinkering with the units. Now for part B, I think you just need to take your time and just sort of work your way through. So we're doing 630 kilometers in an hour, so in 60 minutes. Now we've got to move to meters per second, so why don't we just start off by converting this into meters. So how do we convert from kilometers into meters, where there are 1,000 meters in a kilometer? So if we take our 630 kilometers, multiply this by 1,000, we can see that we're traveling at a speed of 630,000 meters in 60 minutes. Now if I just choose to divide that by 60, now I've said by 6 here, but I mean by 60. We're dividing by 60 to convert from 60 minutes into 1 minute. So we're dividing by 60 here. So divide by 60. So dividing by 60, we can see that we're doing 10,500 meters in 1 minute. So we've taken off 630,000, we've divided by 60. So that's 10,500 meters in 1 minute, or in other words, in 60 seconds. If we then divide by 60 again, that gives us 175 meters in 1 second. So 175 meters per second. Question 9. So in blue, I've chosen to solve this by eliminating my x's. So what I've done, I've taken the second equation here and I've chosen to double everything. So when I double everything here, I get 4x minus 2y equaling 18. And then if I then line that up with the opening equation, I can see that I can eliminate my 4x's if I choose to subtract the second equation from the first. So 4x take away 4x is nothing. Minus 2y minus 5y is minus 7y. And 18 minus 4 is 14. So minus 7y equals 14. Divide through by minus 7 and I can see that y equals minus 2. So y is minus 2. Now to work out the x value, I just substitute this y being minus 2 back into either of the equations. Now I've chosen to use the first one. So 4x plus 5y equals 4, but I've just worked out that y is minus 2. So I can replace the y with a minus 2. So 4x plus 5 lots of minus 2 is 4x minus 10 equaling 4. Add 10 to both sides, divide by 4, and I get x being 3.5. Now up here in black, I've just shown you could have chosen to do it the other way around just by eliminating the y's. So if I'd taken my second equation and multiplied everything by 5, I would have got this, and I could have compared that to my first equation. Now on this occasion, because my y's, which have the same numerical value but a different sign, in order to eliminate the y's, I would have had to choose to add the equations together. 10x plus 4x is 14x, minus 5y added together with plus 5y is nothing, and 45 add 4 is 49. Divide through by 14, I would again have got x being 3.5, and then substituting this into either of the equations, I did the first, I would again have got y equaling -2. Question 10. So I've got to find an equation for this straight line L. So think about your starting point. Think of y equaling mx plus c, where m is the gradient to be found and c is the y-intercept to be found. So how do we work out the gradient? Well, we take a triangle of our choice. I've taken this one here with nice whole numbers, and then the gradient is the y-step, that's the amount up. So the height of the triangle, which is 3, divided by the x-step, which is the base, which is 2. 3 divided by 2 is 1.5. So m is 1.5. Now c is where the line crosses the y-axis, and we can see it's crossing here at +1. So y equals 1.5x plus 1. Now question 11. So we're going to make one comment with regard to the median, and we're going to make one comment with regard to the interquartile range. But to make sure that we pick up both the marks, we've got to make these comments in context. So don't just state the maths, just put it into a real life context. So kicking off with the median, which is obviously one of the measures of average, we can see that the median is higher for science. So what is that telling us? Well, that's telling us on the whole that students got higher marks in science. So you've just got to put it in context. Now, with regard to the interquartile range, remember the interquartile range is a measure of spread. So please get spread written into your answer. And remember that the smaller the interquartile range, the smaller the spread, so the more consistent the marks are. So you need to say something along the lines of the interquartile range is lower for maths. As the spread is lower in maths, the results are more consistent in maths. So please try and get the word consistent into your answer. And remember, the smaller the interquartile range, the more consistent the marks are. Question 12. So part A, remember anything to the power of 0 is 1. Now part B, we just need to attach this cubing to each of the components. So 3 cubed means 3 times 3 times 3, which is 27. And then once we move on to the powers, remember where you've got a power inside the bracket and a power outside the bracket, you multiply these numbers together. So x to the power of 2 times 3, which is 6, and y to the power of 5 times 3, which is 15. Now with part C, just be careful. When it says fully, you know you're going to be having to do more than just taking out a single component. So sure, your opening start is to notice that we've got a common factor of 2. So this is partially factorising it. Now remember, when you've got something being squared and then you're taking away a square number, this is called the difference between two squares. So e squared minus 9 is e plus 3 times e minus 3. Because e times e would give us our e squared. E times minus 3 would be minus 3e. Plus 3 times e would be plus 3e, so those two terms would cancel. And then our final clause would give us 3 times the minus 3, which is our minus 9. So just make sure you circle the word fully to remind yourself to do more than just simply take the 2 outside. Now for part D, making R the subject. Now not that easy, but if you've just remembered the strategy, it's not too bad. The complication of course being that we've got our new subject R occurring more than once in the question. So let's start off by undoing the square root. So square both sides, and remember the next step is to just try and make it a one level, a single tiered problem. So rather, we don't really want to have this fraction, so let's undo this dividing by 5r by choosing to multiply both sides by 5r. So 5m squared r equals 6a plus r. Now the next step is key. You want to get all your terms which include an r on one side and all the terms which do not include an r on the other. So on this occasion I've just got to choose to subtract r from both sides, and then both these terms have got an r in them. None of these terms on the right have an r in them. Now once we've done this, we can factorise. This is the key bit. So we take an r outside the bracket, so r open bracket 5m squared minus 1 close bracket equals 6a. And now for the first time in the question we've just got r appearing only the once. It's twice here, twice here, twice here, twice in the question. We've now got it appearing just the once. So we can then just divide through by the 5m squared minus 1, giving us r equaling 6a all over 5m squared minus 1. Question 13. So this was a little bit different. On this occasion we're told the mean and we've got an unknown in the table, but just work through the normal process and just sort of work backwards. So how do we work out the mean when we've got a frequency table? Well, 5 times the 4 equals 20, 6 times the 13, and so on. So we cross multiply, we would then add up all these final numbers and divide that total by the total of the frequencies. Now obviously on this occasion we're missing a part of the data, so we can't, it's not quite as simple as normal, but we can still do 5 times 4 is 20, 6 times 13 is 78, and so on. Okay, 8 times x is 8x. We can do all the others. Now when we add up the final total, we've got 264 plus the 8x, and when we add up our frequencies we've got 39 plus an x. Now how do we work out the mean? Well, it would be this divided by this gives us our mean of 7. So 8x plus 264 all over x plus 39 equals 7. So we've constructed an equation which we need to solve. So choose to multiply both sides by x plus 39. I've then multiplied out my bracket, and then at this point I've just subtracted 7x and subtracted 264 from both sides to give me x being 9. Question 14. So quite a nice part A here. So remember the branches on a probability tree add up to a whole. So this must be 0.65 because 0.35 add 0.65 as a whole. And then we're just repeating the pair of values over here. Now work out the probability that Marcus wins at least one of the 2 games of tennis. So at least one of them. So it's all 3 of these options here. He might win them both, so it might be a win-win, or it might be a win-lose, or it might be a lose-win. So in fact the only branch we're not interested in is the lose-lose. So the quickest way to work out the answer here is to work out what lose-lose is and then take that away from a whole. Alternatively, of course, you could just work out the 3 to get here. So you could do 0.35 times 0.35 and add on 0.35 times 0.65 and add on to that 0.65 times 0.35. But as I said, the quickest way to work this out is to work out this journey here that we don't want. So 0.65 times 0.65, which is 0.4225. Take that away from a whole to give us the answer of 0.5775. So 15 part A, we've got to show that this applies. So be ever so careful here. The danger is just to launch in to try and solve this quadratic equation. But they're not asking you to do that. We've got to construct this. We've got to show that this applies. So the secret here is to appreciate this is an area of a trapezium problem. So looking at the front of the paper, you can see that the area of a trapezium is half of a plus b times h, where a is x plus 5, b is 3x minus 2, and our h is 2x minus 3. So we're just going to plug these 3 into this formula. And what do we know about that area? Well, that area equals 133. So half times a plus b, so that's the x plus 5 plus 3x minus 2. And then that's multiplied by h, which is 2x minus 3. Now, I've just tidied up this opening bracket here. X plus 3x is 4x, and 5 take away 2 is plus 3. I've then chosen to multiply through by 2 to undo this half, giving me this. I've then multiplied out this pair of brackets. 4x times 2x is 8x squared. 4x times minus 3 is minus 12x. Plus 3 times 2x is plus 6x. And plus 3 times minus 3 is minus 9. I've then tidied up the left hand side by adding these two terms together, given me this. Then I've taken away 266 from both sides, and that's given me what I had to show. Now for part B, I'm going to solve this to find the value for x. So I'm going to use the quadratic formula which is given. So a is the coefficient of x squared, which is 8, b is minus 6, and c is minus 275. So popping that into the formula, I can see that x equals 6 plus or minus 94 over 16. Now just have a care here, x is going to have to be such that we get some lengths. So x is going to have to be bigger, it's going to have to be the positive value, because 6 take away 94 over 16 is going to be giving us negative values for x, which can't be the case because we don't want to be getting, we can't be getting negative lengths. So we only want the positive value. So that's 6 add 94 divided by 16, which is 6.25. Again, we should have seen, if we read the question carefully, that we were only trying to find the value singular for x. So again, that should have taken us away from possibly giving two solutions. Question 16. So we have a 3D similarity question here. So let's kick off with the ratio that we've been given. We've been given the volume ratio of 405 to 960. Now you don't have to simplify them because of course you've got a calculator, but I've chosen to do so. So I've divided by 5 and divided by 3, and that's given me these nice cube numbers to work with. So how do you move from the volume ratio to the length ratio when you have to cube root? So cube root of 27 is 3, and cube root of 64 is 4. So that gives me my length ratio, but I want to be working with my area ratio. This question is asking me to work out an area. So how do we move from the length ratio to the area ratio? We square. So I've squared 3 to get 9, and I've squared 4 to get 16. So the area ratio that I'm going to choose to work with is 9 to 16. So that's what I've taken over here. Now I'm told that the surface area of B is 928. Well, that's 58 lots of 16. I've just done 928 divided by 16. So it's 58 times as big as my ratio. So 9 times 58 gives me 522 as the surface area of A. Question 17. So for part A, we've just got to work out f of 5, so we just pop 5 into the f function. So 4 take away 3 lots of 5, 4 take away 15 is minus 11. Now for part B, find the value of x that cannot be included in any domain of G. So what values would this give us no real solutions? Well, you can't divide by 0. So what value of x would give us 0 for the denominator? So 1 minus 2x equals 0. So when x is a half, this would be undefined, because 1 take away 2 lots of a half is 1 take away 1, which is 0. So it'd be 1 divided by 0, which is undefined. So x being a half. Now for part C, be careful. You've got to pop minus 1.5 first of all into the g function, and then take that output and put it into the f function. So make sure you get it the right way around. So popping minus 1.5 into the g function, I get 1 divided by 1 minus 2 lots of minus 1.5. Well, minus 2 times minus 1.5 is plus 3. So it's 1 over 1 plus 3, which is 1 over 4. So I now take this quarter and I substitute that into the f function. So 4 take away 3 lots of a quarter, 4 take away 3 quarters, which is 3 1/4, or 3.25. question 18. So I've gone and worked out the maximum values for x, a and m, so the maximum and minimum. So 8 correct to one significant figure. Well, the smallest this could be is 7.5, because that would round up to 8, and the maximum value is 8.5. Now just remember, with bound questions, we just look for the symmetry. So as we've gone down 0.5, we go up 0.5. Okay, we all know that 8.5 would actually round to 9 in the real world, but think of this as 8.49 recurring, because 8.5 is all but down the same number, and 8.49 recurring would round down. So please don't overcomplicate things and start using 9 recurring, just keep the symmetry. So with regard to A, correct to 2 sig figs, well 4.55 would round up, 4.65 would round down. Now correct to the nearest 10, 15 rounds up to 20, and 25 rounds down to 20. So these are the values that I may need to use to work out my answer. So I've got to work out the lower bound of p. So I want to make p as small as possible. Now when you're dividing, to get the smallest possible outcome, you want the numerator, the top bit, to be as small as possible, and the denominator to be as big as possible. Now how do we make this denominator as big as possible? Well, we want the upper bound for m, and we subtract the lower bound for x. So that overall will make the denominator as big as possible, that is as small as possible, so overall that gives us the lowest possible value for p. So just picking up the appropriate value here, we wanted the lower bound for a, which is 4.55, we wanted the upper bound for m, which is 25, and we subtracted the lower bound for x, which is 7.5. So popping that into a calculator, we get 13 over 50, or 0.26. Question 19. Now remember, with histograms, the area represents the frequency. So we need to work out the area of each of these bars. So this first bar here has got a base of 2, height of 2.5, 2 lots of 2.5 is 5. This bar here has got a base of 3, a height of 4, 3/4 of 12. This one here, base of 5, height of 3.4, giving us an area of 17. This one here has got a base of 5, a height of 2.2, giving us an area of 11. And this final rectangle here has got a base of 15, a height of 1, so an area of 15. So our total area, our total frequency, is 5 plus 12 plus 17 plus 11 plus 15. Now we want to work out an estimate for the proportion of these people who waited longer than 20 minutes. Well, here's 20 minutes, so we want the proportion, this area beyond 20, this proportion here, divided by the total area. So this little area here, the greater than 20 minutes, we've got a base of 10, a height of 1, giving us a numerator of 10, and then our denominator is adding together all our total areas, which is 60, so 10 over 60, which is a sixth. Question 20. So nice little question this, I thought. So the first thing we can work out is this angle here, CDB. Now that is x as well from the alternate segment theorem, so that's one of the circle theories. Now given that that is x, that's CDB, that blue angle there, we can also say that this purple angle here, CAB, is also x. It's sort of like that bow tie effect, that circle theory. So so basically CAB also equals x because angles at the circumference are equal in the same segment. Do remember to say that, okay? It's in the same segment. Now given that that is x, we can also say that angle ACB is also x, and that's because a triangle ACB is an isosceles triangle of which base angles are equal. Now if those are both x, then this angle here, this angle ABC, must be 180 take away 2 lots of x, because angles in a triangle add up to 180, and we've got x, so this angle here is got to be 180, take away these two x's. Now, because we've said that angle ABC equals 180 minus 2x, then angle ADC we can now work out, because what do we know about opposite angles in a cyclic quad? They add up to 180. So if we take 180 and we take away 180 minus 2x, that tells us what this angle ADC is. And 180 minus 2x is 2x. So we've now proven that angle ADC equals 2x. So make sure you just work your way through and give reasons for each stage in your working. So each fact needs to be backed up with the maths underpinning it. Question 21. So we are told that the lines are perpendicular. So we're going to need to know what the gradient of M is. So to kick off with, let's work out what the gradient of L is. So we've been given the equation for L. So let's rearrange this into y equals mx plus c format. So adding 6x to both sides, we get 4y equaling 6x plus 33. Divide through by 4 and we've made y the subject. So y equals 6 over 4x plus 33 over 4. So y equals mx plus c. So the gradient of the line L is 6 over 4, which is 3 over 2. Now, because line M is perpendicular to L, the gradient of M is going to be minus 2/3. Okay, we flipped it over and changed the sign, or more formally, minus 2/3 times 3 over 2 would equal minus 1. So we know the gradient of M is minus 2/3. Now, how do we work out the gradient? Is the y step take away the x step? So if we look at the difference between the y coordinates and we divide that by the difference between the x coordinates, that equals our gradient, that equals minus 2/3. So the difference between k and 6 is k minus 6, and the difference between minus 4 and 5 is minus 4 minus 5. So we've constructed an equation here which we can solve. Minus 4 take away 5 is minus 9. Minus 9 times minus 2 over 3 is 6. So k minus 6 equals 6 when we multiply through by minus 9. Adding 6 to both sides, we get k equaling 12. Question 22. Now I thought this was difficult, but then fair enough, you expect to get one or two difficult questions in a paper. So what's this question all about? We're talking about the area of the base of the cone and the total surface area of the cone. So let's just kick off by reminding ourselves what these are. So the area of the base of the cone, well, it's a circular base pyramid, it's a cone, so the base is a circle. So that's just going to have an area of pi r squared. Now the total surface area of the cone, just from, and use the formula sheet at the front to help you. Well, the total surface area of the cone comprises the base, the circle, pi r squared, added together with the curved surface area, which is pi rl. So the total surface area is the two added together. Now, we are told that the ratio of the area of the base to the total surface area is 3 to 8. Now that's the ratio. Now if I want to form an equation, I've got to take the area of the base of the cone and multiply that by 8 to make it equal to the total surface area of the cone multiplied by 3. So just think what we've done here. To make these equal, I'm taking the first one and multiplying it by 8 and taking the second one and multiplying it by 3. So 8 lots of the area of the base, so 8 lots of pi r squared equals 3 lots the total surface area, so 3 lots of pi rl plus pi r squared. So I've constructed an equation. Now multiplying out the brackets on the right hand side, I get this. then taking away 3 pi r squared from both sides, I get 5 pi r squared equals 3 pi r l. Now dividing both sides by pi and dividing both sides by r, I get 5r equaling 3l, or to make r the subject, dividing both sides by 5, I can see that my radius equals 3/5 of the length. Now I'm going to move over to SOHCAHTOA now. Okay, I'm going to call this angle here, this acute angle here between B, V and the origin theta, and I'm just following the lettering that the formula sheet gives us. I'm calling that the height, I'm calling that the radius, I'm calling that the diagonal length. Now I know that sin theta equals my opposite over my hypotenuse, which is r over l. So sin theta equals r, which is 3/5 l, divided by l. So my l's cancel, and I can say that sin theta equals 3/5. So inverse sinning both sides, I get theta equaling 36.86 dot dot dot. Now I want to work out the size of the angle AVB, so that's 2 lots of theta. So 2 lots of 36.86 dot dot dot, which is 73.73 dot dot dot, which is 73.7 degrees to 1 decimal place. Question 23. Now I think with these vector questions, these column vector questions, a quick sketch just helps you gather your thoughts. So it doesn't have to be that accurate, but just broadly right. So we know that d to a is -2, 3, so 2 to the left and 3 up, and d to b is 1 to the left and 7 up. So what I'm going to do first of all is work out what the vector from A to B is. Now to get from A to B, I go from A to D and then D to B. So I go down this the opposite way. So A to D is actually going to be 2 minus 3, and then I add on my D to B, which is -1, 7. So my vector to take me from A to B is 1, 4. Now I'm told that my D to C is 3 lots of my A to B, so 3 lots of my 1 to 4, which is 3 to 12. So to get from D to C, I go 3 to the right and 12 up. So I've just popped that there to help me gather my thoughts. It's roughly that. Now I want to go from B to C, from B to C. So I've got to go from B to D and then D to C. Now B to D is the opposite way down, -1, 7. I'm not going from D to B, I'm going B to D. So that's going to be 1 minus 7. And then D to C, I'm going the right way, so that's just a 3, 12. So adding those together, I can see my vector to take me from B to C is 4, 5. Now if the question had asked for the vector BC, that would be my final answer, but it doesn't. It asks for the exact magnitude of BC. So the magnitude means the length. What is the length of BC? And the fact that it's asking for it to be exact would probably mean I'm giving my answer in square root format. So I've got to get from B to C, I go 4 along and 5 up. So it's a Pythagoras question. 4 along and 5 up. The overall length is going to be the square root of 4 squared plus 5 squared. There's my 4, there's my 5. And that is the square root of 41.